Hello, my young scientists. Today I wanted to give you a lesson about electrical energy, and that is the same thing as electricity. It's something that we use every day. In fact, if you're watching this video, you are using electricity because the computer or phone or screen that you're watching it on is using electricity to both give you the sounds and make the light that shows the picture of me. So we use electricity on a daily basis, and it's useful to know something about it scientifically. So, before we start talking about electrical energy, I want to talk about what energy is first. So, what is energy? The simplest definition of energy is the ability to do work. And that's kind of a funny definition, but when you think about it, it does make sense, especially in a scientific sense. Scientific work is a little bit different than the homework that you think of. Basically, it means that you can do things with it. So it takes energy to heat up a bowl of soup in the microwave. It takes energy to do that, or to turn on a light bulb. That light is energy. And to move, it takes energy. There's energy all around us. And it actually comes in a lot of different forms. So there's not just one form of energy. It can be in lots of different forms. So it could be in the form of light. So when you turn on a light bulb, that's energy. Heat. So when you have a hot stove, that is energy. Sounds. My voice coming to your ears is coming in a form of energy, sound energy. Movement. So as I move my arms, I am using energy to produce that movement, and then that energy is kind of caught up in the motion of my arms. That's why it's hard to stop a car, because there's a lot of energy. So you can't just push on a car on the highway and make it stop. There's also something called potential energy, and you'll learn more about that in a few years. But potential energy is basically if you take a ball up to the top of a hill and then you touch it, it has all this potential energy built up because you brought it up high so it can roll back down. There's something also called chemical energy, and that's kind of like what you learned about with fire. So there's chemical energy in the wood, in the molecules of the wood holding it together, and when you break them apart, that energy is released in the form of light and heat. So it's bound up in chemicals. And lastly, the one we're going to focus on today is electrical energy. Now, there are more kinds of energy than just this, but this is a good way to get you to think about the different forms of energy that are out there. But today we're going to focus on electrical energy. But one very important point, and this is what makes electrical energy so useful, is that you can actually turn energy from one form into another. So if I look back at that list of different energies, I can change electrical energy into sound energy. And in fact, that's what your computer is doing right now. The electricity is going and making the speakers move and vibrate, making sound energy. Likewise, if you put toast in a toaster, that electricity is turned into heat energy. So we can turn electrical energy into other forms of energy. And along the same line of thought, we can actually turn other forms of energy into electrical energy. So this is actually where we make energy. We're going to talk about that a little bit later, but we can actually use turbines and things to convert motion into electricity, which is really, really interesting. So just remember, we can convert from one form of energy into another. So then that leaves us with the question, what is electricity? So now we know what energy is, but what is electric energy? And simply defined, it is the flow of electric charge. Now, electric charge is another way of saying electrons. And this is another thing you'll learn later on in your science classes. But everything in the world that is made of stuff is made of these tiny little particles are called atoms. And atoms have what are called electrons flying around them as part of the atom. And when those electrons move from one place to another, that is electricity. So you can think of it as these very tiny little particles that jump from one thing to another. And I won't go into more detail than that right now. You can ask a student who's been through chemistry, and they can tell you all about the structure of an atom and electrons and other good subatomic particles. But for right now, you just have to know that there's these tiny little particles that move around, and that is electricity. So here is a common sight of electricity, and as the summer starts to come in, we might see some more of this, and this is lightning. And this is actually a great example of how electricity works. So electrons, those little particles that float around, that move around, and which cause electricity, electrons actually have what is called a charge, and basically they like to be even. So kind of like if you were to dump a bucket of water right onto the table in front of you, that water would spread out and make itself even across the table. It wouldn't just, stay in a big lump right where it was. It'll flow out. Electricity is kind of like that. Where there's a lot of electrons in one place, they don't really like being right next to each other, and they're going to spread out as much as they can. So electrons like to spread out. And so when we have a lot of electrons right next to each other, we call that a negative charge, because electrons are negatively charged. So when you have a lot of electrons right next to each other, that's a negative charge. And when you don't have many electrons right next to each other, that's called a positive charge. And so on here, I put a little plus and minus to represent a negative and a positive charge. So the minus sign up at the top means there's a lot of electrons up here in that cloud. And the plus down at the bottom means there's not as many electrons down in the ground here in this picture. So there's a lot of electrons in the cloud, giving it a negative charge, and there are not as many electrons in the ground, giving it a positive charge. And I can even draw this out by adding some electrons into the drawing here. So I put 6 electrons in the cloud and 2 down in the ground. And in reality, there's trillions upon trillions upon trillions. We're just going to use smaller numbers so we can you can picture each of these circles being trillions of atoms, and then it would work. So basically, there are more up here than there are down here. So remember what I said earlier, that electrons like to spread out and become even? So because there's so many up in the cloud, some of them are actually going to, at some point, when they can't take it anymore, they're going to actually jump down to the ground. And when they jump down to the ground, that is what lightning is. It's that electric flow. So electrons moving from the cloud down to the ground to balance out that charge. So I have a little animation here to show you. So you're going to see some of these electrons in the cloud jumping down to the ground. So remember, there's 6 on top, and whoop! Oh, look, now there's only 4 up in the top in the cloud, and there's 4 down in the bottom, so they've evened it out. And that's basically how lightning works, is when there's so many electrons up in the cloud that they can't take it anymore, they actually jump down to the ground to help balance that out a little bit. And that's where we get lightning from. So this is just a demonstration of how electricity moves. It moves from places where there's a lot of electrons to places where there are not as many electrons. And we can think of this in terms of a battery as well. So have you ever noticed on a battery how there's one side that says plus and one side that says minus? And when you put it in your toy robot or toy car or toy whatever, you have to actually get the plus and minus lined up correctly, otherwise your toy won't work. That is because the electricity has to flow through the toy in the correct direction, and that's where we have a plus and a minus side of the battery to represent like the positive and negative sides. So with this battery here, the end that has the kind of golden end with a little bump on it, that's the positive end, and the other end is the negative end. So the electrons are going to be actually down at the negative end with the minus sign. And the thing with electrons is, as much as they want to get up to that positive side, they usually need something to go through. And they don't go through air all that well when they're in low charges like this. So that is why you connect it to wires, or when you put it into your little battery pack, there's a little spring, that metal that touches it. Electrons love going through metal. That's like a highway for them. They can go real fast through metal, and it's nice and easy. And so if we were to connect some wire to one end of the battery and connect that all the way to the other, like this, then suddenly the electrons have a nice little path that they can use to get from one end to the other. So they're going to start moving along that path and go from the negative end of the battery to the positive end of the battery. Now, for the record, you never actually want to connect just a wire to a battery. That's called short-circuiting it. You want a light bulb or something in the middle that they can actually do something while they're going through. Otherwise, the wire will get really hot and you could burn yourself. So never connect a wire directly from one end of the battery to the other. That's not good for it. Let's see that again. There's electrons down in the negative end, and they're going to go along the wire to the positive end, and that is how electricity flows. So we use electricity every day, and you might be wondering, well, Mr. Ferris, we use a lot of electricity. Where does all the electricity come from? Because it's energy, so it has to come from some sort of source. And there's actually several different sources of energy that we use here in America. Perhaps one of the most common is burning fossil fuels. And I'm going to talk about each of these just a little bit, and then that'll be the end of the lesson. So we burn fossil fuels to make energy. Another one is a nuclear power plant, and there's some interesting science going on there too. And the last form I'll talk about is renewable energy. These are the three big ways that we actually make electricity. So when you plug something into that outlet in your wall, you're actually connecting to one of these sources sort of indirectly. So these sources make the energy and they send it along the wires and it gets to your house and then you can plug in and use it. So let's first talk about fossil fuels. Fossil fuels is another way of saying things like coal or gas, kind of like the gas that you put in your car, although not quite the same thing. But basically, they're these things that they burn really, really well, and they give off a lot of heat when they're burned. And remember earlier I said we can convert one form of energy into another form of energy. So as long as we can make a lot of heat, we can find a way to turn that into electricity. And that's exactly what the power plants do here. So actually, they're making a lot of steam. So a lot of that smoke you see coming out at the top is actually steam. Although there are some other things in there as well. And we'll talk about that shortly. But basically, they have what's called a steam turbine inside these plants, where they use steam to turn this thing that makes electricity, essentially. I'm not going to go into all the science of how that works, and we can talk about that some other time if you'd like. I'd love to talk about that. But basically, they can push electrons through a wire and make electricity. And so fossil fuels is a good way of doing that. The problem with fossil fuels, however, is that it's not the cleanest way of making energy. So there are some pollution. There's some pollution that comes out and gases that come out of the smokestacks that we don't really want to be making a lot of. And so sometimes people don't like using fossil fuels for that reason. Another thing about them is that we don't have an unlimited supply of fossil fuels in the earth, because we dig up coal and such from the earth. And so when you run out, you run out. And so we don't want to run out of all of our supply of these natural gases and coal and everything like that. So a lot of people are looking to find better ways to make electricity than fossil fuels now. And that's what's called renewable energy. And we'll get to that in a couple of slides. But first, I want to talk about a nuclear power plant, because this is another really cool way of making electricity. And if you've ever heard of 3 Mile Island down right near Harrisburg, actually, there's actually nuclear reactors there, and there actually was a problem there where one of them actually kind of had a meltdown, and it's shutting down now. But a number of years ago there was a problem, and so nuclear energy, anyways, is without going into too much detail, basically you're breaking apart atoms. So remember those little tiny pieces that make up everything? You're breaking those apart and taking the energy from inside them. So it's sort of like burning something, but you're burning it so extremely that you're breaking apart the atom. It's not really burning, but it's a good way to think about it, maybe. And then what they can do is use that to heat up steam and then, again, move turbines. So these are big power plant stacks right here. You can see lots of steam coming out. A nice thing about nuclear plants is they actually don't cause as much pollution as fossil fuels, so they're a little bit better of a way of making electricity. And they're also very efficient, too, so you can get a lot of energy from those. But still, they're not perfectly ideal in certain ways. Like if one of them breaks apart, you could get some dangerous radiation going out and hurting people. So there are some things that are less than ideal about a nuclear power plant. And that's why a lot of people are looking for new ways of producing electricity. And like renewable energy is a broad term that describes lots of different ways of making electricity, using things that we can renew, that is, use again and again and again. So one of those is sunlight. You can see on this house here there are solar panels. And basically what they're doing is they're taking light energy from the sun and converting that light energy into electrical energy. So as you drive around, you probably see a lot of houses that have solar panels, and that's one source of renewable energy. A second source of renewable energy is wind turbines. And you might see these when you're driving along the mountains. You see these big, what look like windmills kind of spinning on top of the mountain. And what they're doing is they're taking that moving energy from the wind, and that wind is moving the propellers around, and that's moving a turbine, and they can use that to make electricity. Now the nice things about these is that we don't have any pollution generated as a result of this, and you can keep using it over and over and over again. You don't have to worry about like burning your coal and then you're done with it. You can't burn it again. You can always keep harvesting more wind or sunlight. But there are problems with these as well. They're usually not as efficient as the other ways of making electricity. And it's kind of hard to find a place to put a lot of wind turbines too. It can be hard to find that, and it can be expensive. But other than that, it's a great way of making energy, and it's nice and clean and good for the environment too, usually. So anyways, that is all that I have to talk about electricity right now. I hope that I maybe opened your mind up a little bit as to where the energy that is going into your computer, which is making me speak to you right now, where that energy is actually coming from and how electricity works. There's a lot of really fun things that you can do with it, and we can explore that another time. But until then, take care. Have a good week.